I just checked out the Google form and there are 10 questions or 10 of them that you guys have questions on. So I'm gonna go over those this morning. The ones that people asked about were 13, 14, 22, 24, 25, 29, 30, 33. Hopefully that Google form was a good way to ask you those things, other than maybe people thinking, oh gosh, that was too much work to do at once. But I wanted to make sure I could get these done this morning so that you had them for class time. And then technically we don't have class Tuesday or Wednesday, Thursday, because they're day twos. So I'm going to be giving you these answers, and then I'm going to tell you what else is going on. Okay. Actually, I'll just be writing them in the Google Classroom. Sorry, it's very early. So here we go. So I'm going to start with, hopefully there's enough light. Oops, this is falling. Okay, I'm going to start with number 13. So for number 13, the way it's written with x over 2, I think about this before I even start as 1/2 x minus 1/4 sine 2x. I don't have to necessarily write it out like that, but that's how I'm thinking about it as I do my work, so that I'm not worrying about quotient rule or anything like that. So when I go take the derivative, you know, if this was just 5x, you would know the derivative was 5. Now it's 1/2 x, the derivative is 1/2. Great. Over here I have 1/4 times the derivative of sine of x, which is 2x times 2. So then I went through and I just, I should check the answers just to make sure I have the answer down right. So then I just reduced things. So this is a 2 as a multiplier, this 4 is, or 1/4 is a multiplier, so I canceled these and made 1/2. That's how that came to be. So let me let my dog in so he doesn't keep barking. No, just there. Okay, let's try 14. It looks like maybe I got number 14 wrong because there were a couple questions about it and I saw there was a comment in the classroom about having the answer wrong. So let's do it again and see what I come up with. So I wrote out the original as, I guess I decided to do it as a product, huh? I wonder if you guys did that or if you decided to do it as a quotient. So let's do it as quotient rule and see what happens. So I have 3x over x squared plus 1 to the 1/2. So let's do this as quotient rule. So the derivative would be the bottom times the derivative of the top minus the top times the derivative of the bottom, 1/2 times x squared plus 1 to the negative 1/2 times 2x. All of that would be over the bottom squared. So this answer is going to look a lot different than my answer did. Be quiet. Shh. It's going to look a lot different than my answer did because I just did it a different way, but let's see what we get to with this. So I'm going to have 3 root x squared plus 1 minus, so the nice thing about this, it's still going to be ugly, but whatever. This 2 and this 2 can cancel. So I really have 3x squared over the square root of x squared plus 1. And then I have that all over x squared plus 1 because the 1/2 and the 2 will end up canceling. So you could also leave your answer like that. If I were going to reduce it more, I don't know. It's early and you really don't have to get that nitty gritty with it. So that's fine. Okay, don't stress out too much about the reducing of some of these fractions, the big gnarly ones, because you're rarely going to be asked to do that. Okay, there's 14. So next we are 22. Okay, so 22, I'm looking at this original problem as the cosecant of 3x plus 1, all of that raised to the third. That's what that little tiny 3 means. It means that entire thing is raised to the third. So this is a big chain rule problem. So chain rule says deal with the outside thing first, which is the third. So bring the 3 down and then, leave this exactly as it is. Subtract 1 from the power and now multiply by the derivative of the inside. So the derivative of cosecant is negative cosecant cotangent. And I have 3x plus 1. And then I still have to multiply by the derivative of that inside part. And I'm checking my work over here to make sure I have the same thing. Yep. Okay, so that's what happened. I had a big chain rule. And then, so I had to chain on the derivative of cosecant. And then I had a little tiny chain rule on the inside, chaining on the derivative of the 3x plus 1. When I put that all together, I have this on the outside. I've got a 3 and a negative, so I have negative 9. And then I figured for cosecant 3x plus 1, I have 2 of them here and one of them over here. So I have 3 of them total. And then I have a cotangent 3x plus 1. So that's how I got to that answer. All right, 24. 24 is just a product rule, so unless I have that wrong. So we have sine times secant. So the derivative will be the first term times the derivative of the second, and the derivative of secant is, oh crap, did I get that wrong? Derivative of tangent is secant squared. Derivative of secant, yeah. Sorry, I got that wrong. I'll write that down. So the derivative of sine, or sorry, the first times the derivative of second plus the second times the derivative of the first. Okay, so let's see, can I clean this up a little bit? Well, just for giggles, because stuff might cancel. I mean, this is fine if you left your answer like that, but I'd have the sine. This would be 1 over cosine. This would be sine over cosine. So no, nothing really cancels there. And then this should cancel because we'd have 1 over cosine times cosine. So that would be 1. So finally, I'd have sine x, secant x, tangent x plus 1. Wouldn't it be funny if I messed these up now and now you're like, wait, what? Oh, funny. I'm just making a note to myself to go fix 24 later. 24, I was 14 wrong that you guys thought? I don't know, I have to go look at to see if my work was actually wrong the way I did it. Love you too, bye. 24, all right, so let's do 25. I can stay here. Okay, so it looks like I handled 25 like product or quotient rule, so I will again. So we've got the secant of 5x over square root of x, so I'm going to leave that as x to the 1/2. So we're going to have, well, I'll leave it as the bottom times the derivative of the top. So derivative of secant, we now remember, is secant tangent. And I need to multiply by that 5. So bottom times derivative of top, or ho d high minus high. D ho, derivative of root x, is 1/2 x to the negative 1/2. All over, come here. Dog, shut up. The bottom squared. So that's it, that's my work. If you go look at the regular answer, I think I did everything else right. I just reduced this by putting this on the bottom here. And I brought this 5 to the front, but that's it. Okay, 25, 28. Okay, 25 to the sine of x. So this is that, you know, it's hard to remember these, but this is an a to the x problem, or a to the u problem. And the derivative of a to the u is a to the u times the natural log of a times u prime. So for number 28, we have 5 to the sine x. So the derivative of f will be a to the u, so 5 to the sine x, times the natural log of 5 times the derivative of sine. So that's 28. I'm checking my answer. Yeah. Okay, it's a lot. The more you do the problems like this, the easier they just become in your head, because it's like I take this exact thing times the natural log of the base times the derivative of the power. All right, 29. Obviously, you guys did not like these log problems. So we have another log, but now instead of looking at it exponentially, we're looking at it in terms of a log. So the formula for this, something with a log base a. So instead of a natural log, now we have a log that has a base of something that's not e. So remember, natural log of u is the same thing as log with a base e of u. So the natural logs were logs. They just had a base of e, so they didn't require the chain on. And the reason for that is because when I chain on the natural log of that base, the natural log of e is just 1. So when I chain on a base natural, or when I chain on the natural log of this base, it's not just 1. So the derivative of log base a of u in like terms of the formula is make a fraction, put that on the bottom, put the derivative of that on the top, and multiply by the natural log of the base. So for number 29, looking at my answer, the derivative will be put 3x on the bottom, put the derivative of it on top, and multiply by the natural log of the base. That's how that goes. All right, number 30. Which is y equals the sine of 3 to the x. This has that little a to the u in it. The derivative will be, still sine's the outside thing, so we take the derivative of that first with respect to what's inside, times the derivative of what's inside. Well, the derivative of 3 to the x is 3 to the x, times the natural log of 3, times the derivative of the base, which is just 1. So this is 30. Check my answer. Ah, son of a biscuit, I forgot the natural log of 3 in mine. Sorry, I was making that correction. Okay, so maybe that's why people needed help on it, because mine was wrong. Okay, 33. So we probably have forgotten a lot of our log rules. So the derivative of 33 is just 1. If I did it by derivative rules, to take the derivative of natural log, oh yeah, I'm so sorry, I'm so tired this morning. I throw this on the bottom, I take the derivative of that and put it on the top, and then I multiply by the natural log of the base, which in this case I don't have to worry about. So the answer is just 1. But if I had been sleuthy and remembered log rules, the original, this thing is actually just x. So therefore the derivative of x is just 1. Remembering log rules is tough, so log rules. Not logs rule, log rules. Natural log of e, natural log of 1, natural log of 0. Do we know what those things equal? So do you remember the whole rule of logs? So this is asking you, natural log has a base of e. This is asking you e to the what makes e. This is asking you e to the what makes 1. This is asking you e to the what makes 0. Nothing. That's what logs do. What if I have the log 10 of 100? What does that equal? 10 to the what makes 100? 2. What about the log base 3 of 1/9? 3 to the what makes 1/9? Well, obviously 3 squared makes 9, but we had to get that on the bottom, so -2. 3 to the -2 equals 1/9. Those are how logs work. So yeah, just some general log rules. So I guess if we were over here, how do we know that the natural log of e to the x is just x? There's some other rules. So the natural log of e to the anything equals that something. How would I go? So the way to prove that is just to say, okay, well, e to the what makes this. So e to the question mark equals e to the question mark. So that's kind of a quick and easy way of showing that. But anyway, there's a couple log rules. All right, I'll go fix those couple. I'll post this. Tell you what we're doing today. I'm really sorry about how sleepy I am this morning, but I wanted to make sure I got this done before class.